From generative AI in the data center to premium smartphones, next-generation applications require high-performance logic and DRAM fabs. More performance means more transistors per chip, and to achieve this, the industry relies on continuous scaling of transistors and interconnect wiring. Advanced chips contain more than 10 billion transistors and 50 miles of wiring. As the industry shrinks the trenches used to form the wiring, filling them with copper becomes more challenging. This video illustrates Applied's binary ruthenium cobalt liner, a materials engineering innovation needed to scale interconnect wiring to 2 nanometers and beyond. On the left, using conventional liner materials in smaller trenches can lead to voids. These gaps in the copper structure impact chip reliability and yield. On the right, filling the same trenches with Applied's new binary liner enables void-free copper reflow, resulting in low-resistance copper wiring that increases chip performance and reduces chip power consumption. Applied's copper barrier seed solution on the proven Endura platform is the gold standard for interconnect metallization in logic and memory fabs today. We integrate 6 different technologies, including multiple surface preparations, film deposition, and anneals on a single platform under vacuum. The process of filling copper interconnects begins with multi-chamber surface engineering. The surface preparation is followed by an atomic layer deposition, or ALD process, of a tantalum-based material that coats only the desired surfaces. ALD is followed by a densification process that improves the film's barrier properties. Then, a unique binary liner based on ruthenium and cobalt is deposited in the small trenches, resulting in a thinner liner that maximizes copper volume. Applied's binary liner also provides unique surface properties that encourage void-free copper reflow. Every step of the process must be conducted under ultra-high vacuum, without exposure to atmospheric contamination. Finally, Applied's highly directional PVD technology deposits a continuous, void-free layer of low-resistance copper. Our unique system enables cold deposition and high-temperature processing in the same chamber to increase throughput. In summary, we integrate ALD, CVD, PVD, surface treatments, and anneals in one system, under pristine vacuum conditions to achieve void-free interconnects that deliver world-class electrical performance. Integrated materials engineering enables the industry to scale wiring along with transistors to deliver better chips for AI and other leading-edge applications at the 2 nanometer node and beyond.